So, hi, good morning. Welcome again to this another series, a lecture about basic electrical theories. In the last lectures, we discussed what is voltage, current, and resistance, and then what is the mathematical expression that will give us the relationship between the voltage, current, and resistance, which is in that particular case there, the Ohm's law. So we also solved some simple problems, let's say finding the current if given the voltage and then the resistance. Now, in this particular lecture here, we are going to discuss series circuits, the properties of series circuits, and let's solve some problems related to series circuits. But before that, let's discuss first what is the electrical power. The power in our particular case here, the power is just the product of current multiplied to the voltage. Okay? So current times voltage. And then the unit for this particular case here is watts. Okay, so for example, the given, let's solve some problem here. So let's say solve for power if the voltage, if the voltage rated voltage of that particular appliances is, let's say, 220 volts, okay, and the operating current is, let's say, 2 amperes. Okay, so 2 amperes. So if we're going to solve for the power, given the formula here, the power is just equal to the current times the voltage. So in this particular problem here, the current is 2 amperes, okay, and then the voltage is, let's say, 220 volts. So getting your calculator or multiplying this one, so we have 440 watts W. But in most cases, what we need to find is not the watt term, but in terms of kilowatt. Okay, kilowatt. So to convert watt to kilowatt, so we can use this conversion factor, which is 1 kilowatt is equal to 1,000 watt. Or the alternative, depending on the given, we have the 1,000 watt divided by 1 kilowatt. Okay? So in this particular case here, since the given is watts, so we have to remember that the watt of the conversion factor should be on the denominator side. So we have to put the conversion factor here, so which is watt is the denominator, so we have 1 kilowatt. Kasi we want to solve for the kilowatt, so that is why we have to put the kilowatt in the numerator. So kilowatt, and then we have 1,000 watt. Okay, so cancel, cancel. So we have 1,440 divided by 1,000. If you are not sure with the answer, you have to refer with your calculator. So we have 440 divided by 1,000. Okay, it should be 0.44. So in this particular case here, we have 0.44 kilowatt. Okay, so that's the answer for this particular problem here. Now, so let's try to discuss what is the series circuit. So the series circuits is basically how are we going to identify if the loads are connected in series. So very simple. If you have two loads there, okay, so take note in this particular case here, your loads have two terminals. Okay, this is the terminal 1 and then this is a terminal 2. And then let's say you have another, the same load. Okay, so again, so in this particular case here, we have two terminals for this particular load, 1 and 2. So let's call this one as R1, and then let's call this one as R2. Okay, so we can deduce that these loads are connected in series by simply uh, having the only one of the terminals will be connected. So it means that these two here is connected here. However, the 1 and 2 there are not connected to other loads. So in this particular case here, let's say you have a voltage source here. Okay, so that is a series circuit. So a series circuit. So let's say this is the voltage source. Okay, and then we have here the R1, and then we have there the R2. Okay, so we have to discuss the common properties of a series circuit. Okay. we have to discuss the common electrical properties of a series circuit. First, we have to take a look at the voltage, okay? The voltage drop. So as what we can see here, we have the voltage is equal to Vs, okay? So voltage source or the voltage supplied. So that is the Vs. So if there is a voltage source here, the R1 and the R2 as a load will have some voltage drop or the voltage corresponding to the resistance of that particular load. Okay, if the higher the resistance, the higher the voltage. We will explain that one later on, and then we will illustrate that one in a problem solving. Okay, so but in this particular case here, just to illustrate this one, you have to take note that if there is a load there, which is R1, there should be a voltage drop. So let's call this one as the voltage drop one or the voltage drop in R1. Okay, and then in the load 2, we also have the voltage drop in your load 2. Okay, so in series circuit, the total voltage source is equal to the total voltage drop. Okay, the voltage source is equal to the total voltage drop. So it means that the voltage source, Vs, is equal to the voltage drop in your R1 plus the voltage drop in your R2. So this is the relationship with respect to the voltage. So this is the voltage in series circuit. So now let's try to solve for the resistance, or let's try to solve for the current here. So we have to take note for the current. The current, if there is a current flowing in your in your voltage source, let's call this one as I source, okay, and then there's also a current flowing in your load 1, let's call this one as I1, okay, and then there is also a current flowing through your load 2, which is, let's call this one as I2. So in series circuit, the relationship of your IS, I1, and I2 is just the same. Okay, so it means to say that your IS is equal to I1 is equal to I2. So this is the relationship of current in a series circuit. Okay, so now let's proceed with the resistance. Okay, so how are we going to measure the resistance? If you're going to measure the resistance in actual, so you have to remove for the voltage source first. Okay, you should not measure a resistance, or you should not do a resistance reading if there is a voltage source. You have to de-energize the circuit. So it means that we have to remove the circuit. If you're going to remove the Vs there, basically what will happen is just like this one here. So you have the R1, and then you have here the R2, and then going back here. Okay, so this one here this is our R total. Okay, so in our R total here, the R total, if we're going to connect the terminal here and here, so that is the R total. So in a series circuit, the R total is just equal to, okay, so the R total is equal to R1, the resistance in your in your load 1, and then the R2. So you just have to add the resistance of the two variables there. So means that this is the relationship of your resistance in a series circuit. However, if there is also a power, okay, the power is just basically, if there is a power supply, there is also a power dissipation in your loads. So the consumption of the power in each load. So in that particular case there, okay, so if there is a power source here, PS, so this is the power in 1, this is the power in 2. So the relationship of the power is power source is equal to P1 plus P2. This is for the power. Take note that either in series or parallel, the power is always additive. You have to add the powers for that particular loads. Okay, so P1 plus P2. So now, let's try to solve some problems here. Okay, some sample problems. Although we will be solving another problem in sample problems, solve problems, or we will solve the problems that will come out in your written assessment. But it would be better if we're going to solve some sample problems ahead of time. Okay, so now, let's try to put some values here. Okay, and then let's say this one plus, let's say 10 volts. And then you have here a resistance. Okay, let's say the resistance here, let's say 4 ohms. and then the resistance here is 6 ohms. Okay. So the problem here is we have to solve. Let's try to solve first for the uh let's follow this one, the voltage source. So let's try to solve the following. Number one, let's try to solve for the R total first. And then number two, the I total. Number three, we have to solve for the let's say I1. Let's try to check if you understood the problem. Number four, let's try to solve for the I2. And then number five, let's try to solve for the voltage drop in your one, okay, in your load one. So this is the R1, and then this is the R2. So the voltage drop in your R1, and then number six, let's try to solve for the voltage across R2. So it may look very, it looks many, but the solution is very simple. Okay, so now let's try to solve this one here. Let's change the ball pen. Okay, so the R total, if you're going to review, let's go back to the formula. The R total is just equal to R1 plus R2 in a series circuit. So the R total in this particular case here is 4 ohms plus 6 ohms is equal to 10 ohms. So that is the R total. As simple as that. So for letter B, you have the I total. Okay, so the I total. So in this particular case here, to solve for the I total, you have to use the Ohm's law. Okay, again, you can use this one. This is the V, this is the I, and then this is the R. Since what we want to solve here is the current, so you have to put your finger there. So therefore, the formula for your current is equal to V over R. Okay, so since we want to solve for the I total, so it should be the voltage here should be the V total, and then this one should be the R total. Okay, so the V total in this particular case here should be 10 volts. Okay, and then the R total is 10 ohms. So it means that the I total in this particular case here is 10 divided by 10, that is 1 ampere. So this is the answer for your B. Okay, and then for your C, the I1. So take note again, in our discussion on the properties of the series circuit, in the current side here, the current and a series circuit are all equal. Okay, so it means that the I1 here is equal to your I total, so which is equal to 1 ampere. Okay, so for D again, so I2. So the I2 again is equal to your I1, which is also equal to your I total, which is also equal to 1 ampere. Okay, so very as simple as that. So now the V1. If we are going to go back with our diagram here, VIR. Since we want to find for the V, so you put your finger here in the V. So the formula is you just have to multiply the I and the R. Okay? So E or number 5. So the voltage is equal to IR. Okay? So since the problem stated that we are going to solve for the V1 or the voltage across 1, the voltage across here, okay, if we're going to put a voltmeter here, you're going to measure that voltage across there. Okay? So to measure that one or to solve the voltage across that particular load there, so the V1 should be I1 and should be R1. Okay, you have to be very careful. If what we want to do is the V total, so you should have the I total, R total. If you're going to use the V1, you're going to use the I1 and then the R1. So in this particular case here, the I1 is 1 ampere. And then the R1, if we go back there, that is 4 ohms. Okay, so the V1 in this particular case here, 4 times 1 or 1 times 4 is equal to 4. So that is equals to 4 volts. Okay, and then the last, EF. So the V2. Okay, the V2, so same with the E above. So we have the I2, R2. So just substitute the formula. The I2 again based on letter D. So the I2 is 1 ampere. Okay, and then the R2 is 6 ohms. Okay, 6 ohms. So therefore, that is equal to 1 times 6. So that is equal to 6 volts. So that is V2. Now, going back to our discussion a while ago. So we can say that our answers are correct since, okay, checking the V1, okay, the V1 here and the V2 here, if we're going to add those values there, 4 volts plus 6 volts, that should be equal to the voltage source in our circuit, which is equal to 10 volts. Okay, so later on in the next lecture, we are going to do the parallel. Okay, let's discuss the sum of the terms and then the properties of a parallel circuit, which is very, very important. And then later on, the next lessons, we are going to solve another problems that will come out in your written assessment. Okay, so see you in the next lecture.